Okay, and we will we'll get started. I have not graded your exams yet. We are meeting together with the TAs and graders tomorrow. Okay, we're gonna have a big meeting. We're gonna finish all the grading, and so tomorrow evening you should expect to see your grades posted. Okay. That's that. I think you guys are working on your homeworks and whatever, and I don't know if there's any questions or issues there. Some of you guys had emailed me about maybe some grading issues with your homework 2, and you might have grading issues with homework 3 or whatever. This is just a reminder, I don't do any homework grading corrections or anything like that over email. There's just too much confusion, too much stuff. So anyway, if you have issues with grading, come see me in person, okay? Or go see your TA in person, okay? They also have the authority to make corrections as well. So any grading issues to be done in person. Okay. We'll go ahead and continue on in ggplot2, and I think we did a bunch of stuff. And I think we left off somewhere around here. Okay, we said the big idea in ggplot is that we are mapping a column in the data to a visual property. Okay, whether we are talking about dots, and the visual properties are the color of the dot, which is what we have done here. We mapped the color of the dot to the group variable in the data, or whether it's the size of the dot or the shape of the dot, we are taking or even the X position or the Y position of the dot. We are taking a column in the data and mapping it to an aesthetic or visual attribute of our geometric objects. And again, the key thing here is, being part of the tidyverse, and with this kind of philosophy on the grammar of graphics, you have to format your data to be tidy, meaning each variable has its own column. If you want to visualize a variable, it needs to be in its own column. With ggplot, one thing is that you are creating these graphic objects, and you have to ask R to print the graphics. Okay, you have to print the objects. So in base R, when you call something like plot, or whatever it is, hist, or I don't know, box plot or things like that, it produces the graphic for you. Okay. It's technically known as a side effect, but it produces the graphic for you. In ggplot, when you call ggplot, when we do something like geom_point, or if we go back to the original command where we've created the ggplot object, we have stored this ggplot object into this object P, okay? And so far I have never called the command P. We've just said like P plus this, right? But what's been going on is that behind the scenes, when you type the name of something into R, its default action is to print that object, okay? And so what we have to do is we have to we often have to call print, especially if we are creating a plot within a function, or creating a plot within a loop, or something like that, okay? So, for example, I'm just doing something on the fly here. If I say for I in 1 through 10, and I just say I here, is this going to do anything will this print the numbers 1 through 10, or will it just or will it do anything? So when I do this, it does nothing. Okay, like nothing gets produced to the console. When I just do this, it doesn't do that. But I can always, when you're interacting with the console and you type in I, it prints out what it is. So if we want to see what I actually is, we have to call the command print, right? And similarly, okay, if I load up library ggplot2 or something, okay, and I need to make some kind of data set. So here is you know, if I call some kind of data set and I ask it to print right here, it'll show up in the console. And if I give ggplot a command right here in the console, it'll produce our graph. But if we put this inside some kind of loop like this, all right? And this is a silly loop because it's just running this command. Doing something like this isn't going to produce anything, okay? So if you create a plot in here, and you want it to print within your loop or something, okay? You have to explicitly call print, otherwise it's not going to do anything, okay? So when I run this, this will produce the plots, okay? And it'll produce two of them, two identical plots, but you have to call it, you have to explicitly call print, okay? So this is an issue that some students run into because they're so accustomed to whenever they type in ggplot, it produces a plot as they might expect. However, if you put it inside a loop like this, it will not print out the plot. You have to explicitly call print. This is different from base graphics, where if you called histogram on something, it will produce a histogram for every call of histogram. Right? Is that okay? So we have to explicitly call print on the objects that ggplot produces, especially when it's inside a loop or some kind of function like that. Okay. This is something we don't often think about, but just because these commands have been so kind of naturalized into our thing, but when you produce a histogram, okay, the histogram doesn't, what's being graphed is not actually any column in the data itself, okay? And so, you know, if you say, I want a histogram of student heights, you're taking that student height column of student heights, and then you're doing some kind of operation to it before you make the histogram, okay? If you had to make a histogram by hand, this is very clear, right? You have to go through, you have to set up bins, and you have to tally up how many observations are inside a bin, and then you go and you make a histogram and you say, I'm going to make a bar, you know, 5 units tall because that's how many people were in this bin, okay? With something like ggplot, however, its core philosophy is that each column whatever you're drawing in your visualization has to come from a certain column in the data, right? And so the heights of those bars need to be determined by some kind of data transformation. So for example, when making a histogram, there's underlying work that ggplot does for us. Now, thankfully, because a histogram is such a common task, they've kind of hidden all of the commands behind the scenes in geom_histogram, okay? But there's other things that, you know, we just have to keep in mind. If it's not something that's currently represented in the data and is something that is kind of derived from some kind of work done to it, we might have to use a stats option. Okay. you should whenever you're working with a ggplot, you should always, oh my goodness, I don't know why all these windows opened up, but or tabs opened up, but you should always go to the ggplot reference. Okay, so you can always go to ggplot2.tidyverse.org. Okay, I got links in the notes. If you type in ggplot into Google, this will be the first thing that hits anyway. Okay, so it's not very hard to find. And you just go to kind of, if you go to the regular old ggplot site, this is what you'll see. Let me kind of zoom in. I highly recommend downloading this cheat sheet, okay, which contains a lot of like a summary of a lot of the geometries. Not every single one of them, but a lot of them, yes, okay. And you know, and as far as our class goes, we're only going to really cover the most basic ones, such as the point and the line and the bar, okay. But you have all sorts of other options, and they're all kind of listed off here. You know, if you have two continuous, two numeric variables, you know, things like jitter and point and quantile, these are all useful plots to create. Single variable things, you can make histograms and all sorts of stuff, and these are tiny for you guys to see, but when you download it and look at it, it's useful. Okay, but anyway, we'll just talk briefly about these three today, and then I'll leave everything else to kind of just you and your own time, which is something you should do. You know, one other thing. There's a lot of good questions on Piazza. Also on Piazza, I see a lot of people kind of posting errors that they're running into, and that's fine. I would say 90% of the time, if I run into an error, I can just copy the exact error message, put it into Google, and someone on like Stack Exchange will have experienced the error and will have a solution for it, okay? Now, obviously, when you search for your error message, you have to remove things like your variable name, right? If you have a variable name called baseball, don't include that in your Google search for the error message, because if it says like blah, blah, blah in, you know, baseball not found or something, you know, you'll probably not find that exact same error message. But if you do need to include the variable name, just put in something generic like X, okay? And maybe somebody else will have had the thing, but that's often a thing. I see a lot of people posting their error messages. I have no idea what to do with half the error messages I get either, but thankfully, the rest of the internet has asked similar questions. But anyway, okay. So, okay, yeah. Here's the cheat sheet. Here's all the geometries you can get. All right, so we'll start off with some bar graphs. And so here, I'm just taking, I think this is a data set that either comes part of ggplot or the G cookbook, okay? This is PG_mean, okay? And then if you're never sure, if you don't know if you load up a data set, okay, and it's not something that you imported from a CSV file, but it's like, you know, you called the data set, and it's something that exists inside an R package. For an R package to include a data set, one of the requirements is that there's documentation on the data set, right? So if you're not sure what group and weight, what this means, you can do question mark, the name of the data set, okay? And it will pull up the help file, okay? And it says mean of results from an experiment on plant growth. Oh, okay, that's what PG means, okay? And then it says the data set simply has group-wise means of, I don't know, the plant growth data set. I think there was some people were asking about the vehicles data set, which variable represents what, and city mileage and stuff like that. Just type in question mark vehicles, okay? Type in question mark of the data set, and you will get some kind of documentation that if there's multiple variables, it will list them all out, okay? So I think there's like the diamonds data set. We'll take a look at that. If you just say question mark, I've got questions about diamonds here. it will pull up the help over here. Oh, you know what, I forgot. I have to make my screen bigger for you guys. Okay, and as always, you should always update your software. Get the latest versions of packages. Look at the latest versions of latest version of RStudio, and everything else on your computer as well. Okay. A lot of times people discover security issues with an app or something. You should update these things or turn on auto update. I think a lot of phones now automatically update apps because it's just better that way. But okay, anyway. All right, so here we're just making a bar plot of these three numbers: 5.03, 4.66, 5.526, and all we have to do, what are we going to do? To make ggplot, we're going to map the group variable to the x position and the height, the weight, to the y position on the bar. Okay, so you're going to see an aesthetic mapping of group to the x, or x to the group, and y to the weight variable. And then we're going to have to say stat equals identity because we want to actually plot the actual value that we see. Okay, and so there we go. Here's another data set. This is on cabbage. I don't know, experience? No, cabbage something, cabbage experiment. And we've grown different cultivars. I guess there's different varieties of cabbage that you can grow. You go to the grocery store and you only think there's one kind of cabbage, but apparently if you're a cabbage farmer, this is not the case. And we have different dates, and we're measuring their weights and stuff on cabbage. Okay, so anyway, the command we're going to see here, all right, see if you can visualize what this might look like just based on the command we've seen here, okay? We've got date mapped to the x variable, weight mapped to the y variable, cultivar mapped to the fill, and position equals dodge, stat equals identity, okay? So how many colors am I going to see? How many bars am I going to see? How many positions on the x am I going to see?
3 bars, 2 colors.
3 bars, 2 colors, right? 3x is date. We've got 3 different dates: 16, 20, 21. Okay, weight will be the kind of the height of our bar. 2 colors, cultivar, and this is what we see. Okay, date 16, 20, 21. We've got 2 colors: cultivar 39 and cultivar 52, and this is what our plot looks like. Okay, all of these things have been geom_bar. And we've been calling stat equals identity. I'm going to show you an example where we're not going to call stat equals identity. All right. This is the data set diamonds. Diamonds has 53,940 rows. Okay. And one of the columns is the cut. Okay. So I don't know if any of you are planning on purchasing a ring or a diamond or something like that, but there's all sorts of stuff that you have to consider: carat, cut, color, clarity, I don't know, inclusion, no, I don't know, whatever it is, okay? Stuff, right? Cost. And so the cut, you can get like ideal cut, premium good, very good, I don't know, stuff like that. And we want to see the count of these things, okay? So the default behavior is if you just take the one variable, and we say we're going to map cut to the x variable, okay, it will put the cut on the x variable. And in geom_bar, there's no other mapping, okay? Geom_bar will automatically go through all 50 whatever thousand rows, count up how many have ideal cuts, premium, and fair cuts, and things like that, and graph them accordingly, okay? And you can see here, cut, it says ord, kind of for an ordered variable, okay? Kind of like a factor where there's an order to it, okay? And that implies how the values should be sorted on the x-axis, right? Because this is not in alphabetical order. You know, V comes after the alphabet rather than P, but in terms of going from the worst to the best kind of cuts, they are in this order, okay? So this is where that goes there. Okay. Mapping a variable to the fill. We've already seen this, but here is there's a data set called U.S. population change, okay? And we looked at, I think this is going from the, well, I don't know. There's like 2 censuses, and they said, you know, which states grew the most? Okay, from the 2000 and the 2010 census, okay? And we wanted to see, all right, which states had the biggest population increases, okay? And Arizona, within that 10-year span, their population increased almost 25%, which is rather incredible growth for a state, okay? And then there's other, Nevada jumped 35%, which is crazy, but anyway, and so they're going to get a football team now, okay? And so anyway, this is what's going on, and so we want to we're going to do this. We're just looking at the top 10, okay? We just said the rank has to be greater than 40, okay? Because rank normally goes from smallest will be number 1, things like that. Okay, so anyway, we do this, and then we just say we're going to map the abbreviation onto our x-axis, okay? So we got in alphabetical order, Arizona, Colorado, Florida, Nevada, down to Utah, okay? On the y variable is the change that we observed, and we have bar stat equals identity, okay? The fill is the region, which is either going to be the west or the south, and all the large growths have only been in these 2 regions, the west and the south, okay? The east and the northeast and whatever you've got, Midwest. I don't know what the regions are in the data set, but let's see. Okay, I gotta actually look at it, but this is what we have. Now, right now we have the fill mapped to the region mapped to the fill variable, but we can change that, and you can map, say, the numeric variable, such as the change to the fill, okay? And so here we have change mapped to the height of the bar, and change is also mapped to the fill color. And so it's a little bit redundant, okay? However, this further emphasizes that, you know, Nevada is, you know, all the more kind of pronounced versus everyone else. The coloring automatically is given a scale that goes from dark blue, like black, to light blue, okay? You can do other things, such as rearrange the bars to go from lowest to greatest, right? Right now they are arranged on the x-axis by their in alphabetical order based on the state name. But if you change the aesthetic mapping here and saying x, we want to map to reorder based on, take the abbreviation but reorder them based on the change, then the lowest value goes to the left, the largest value goes to the right, and now you have this kind of nice gradient in terms of going from black to a lighter blue to the lightest shade of blue, and you can see there's a significant jump between Arizona and Nevada, first and second place here. Okay. So these are just different options that you can use that can make your graph a little bit better at communicating whatever point you're trying to make. Okay. Yes. Question. Yes, it is possible. I think that is the next thing I did here. Okay. And so here, if you wanted to, if you didn't like this default color of whatever, I don't know what this is, teal and salmon or something, right? If you want to use UCLA's colors, which they look better on my screen than on this projector here. This is the official colors based on the, I don't know, UCLA branding website on the color palette that you're supposed to use here, okay? And so, so anyway, you can do these things by saying scale, fill, manual, right? So we are changing, the scale is how the data gets mapped to aesthetic attributes. So here we're gonna say, we want these two colors going from, whatever, blue and gold. One of these is blue and the other one's gold. So I don't know which one's which. Okay, I think this is, I have no idea. Okay, so anyway, this is what we've got. I think this one's the blue. And yeah, all right, it doesn't matter. So, so that's what we have, okay? So you can specify the colors. This can get a little bit tedious, the scale fill manual. There's a few things where they have like preset colors and you just choose one of the preset things. Here, if you wanted to change the color gradient to say, you know, I don't want to go from black to blue, but I want to go from red to, well, it's blue on my screen, but it looks more purple over here. Oh, the command got cut off. All right. Where did it go? Well, anyway, it's just a different option on scale fill manual for, okay, so here, scale fill gradient, low is red and high is blue, okay? That's what I've done here for this one. All right, is that okay for all of these bar charts? And again, you can always go to, so if you just search ggplot, okay, I guess it's the second thing here, and then click in the reference, and there's all sorts of stuff, okay? So if you want to change things like the scales, and you want to change, you know, the coloring here, these are all of the different options you have that can be done. And then, you know, you can always just click one of the layer things, and you scroll down and they have different examples, and you can say, oh, how do they do this? Okay, that's pretty much how we learn ggplot. Okay, is we just go to the documentation, you say, oh, that looks cool, and then you go down to the examples, take a look at what they've got, and then you can read the rest of the documentation to figure out how it's supposed to go. Okay, let's cover line graphs. Okay, somehow keep shrinking here. Okay, so here I've got column time 1, 2, 3, 4, 5, 7, and demand is a numeric variable. Okay, 8.3, 10.3, whatever. Okay, and so we can just say time gets mapped to X, demand gets mapped to Y, and let's draw a line. Okay. And so line is going to just kind of connect these things. They connect them in the order that they appear in the data. So if your data was shuffled around, it's going to connect them in that order. Okay, so just make sure that that you have it arranged in the way you want. Okay. Here we are looking at a data set where we've got a categorical variable, a factor here, okay? And we are looking at tooth growth data in guinea pigs, okay? And we gave some of them orange juice, and we gave other people, other guinea pigs vitamin C, and we were measuring how much their teeth grew, because who knows, this might affect tooth growth, right? So anyway, now we have two lines. We want to show the relationship between dose and tooth growth length. You know, this will be our X and this will be our Y, okay? And then we want the lines drawn according to the factor, okay? Whether it was orange juice or vitamin C, okay? So here we've kind of done this, and so here we've mapped dose. What's going on? Okay, so the dose, which is 0.5, 1, and 2, gets mapped to the x-axis. The tooth growth length gets mapped to the y-axis, and the color of the line is mapped I'm sorry, whether it was orange juice or vitamin C gets mapped to the color of the line. And so that's all we're doing here, okay? If you're gonna print something on a black and white printer and you don't have the option of using colors, okay, you have the ability to specify the line type. And so here we have a dotted line and here we have a solid line, okay? And again, ggplot is really great in that it automatically creates these little legends for us, which are super helpful, okay? So we have that as well. I don't know what else I need to say about line plots. I think that's about it. All right, as far as scatter plots go, I think it goes kind of, as we would expect. And let me just kind of show you the head of this height weight data set, okay? We've got different values, sex, the age in years, their age in months, the height in inches, and their weight in pounds. So apparently we were not satisfied with somebody saying that I'm going to turn 12 next month, but we said, oh, you are, it's currently February and your birthday is in March. Well, that makes you 143 months old and you are 11.92 years old. So, and then we measured their height and their weight, and so we have all of this data gathered, okay? And so we have plotted this, okay, and we have the heights of basically kids going from around 11 to looks like 17, 18 years, okay, so middle school and high school aged people, and we are graphing the relationship between year and height. And we can see that in general, as the years go on, the height increases. Maybe it levels off here. It's hard to say, okay? But there's other variables that we can map to attributes on the plot here, okay? So here, so one thing we can do is we can change the shape, and I don't know if you guys can see the difference here. Oops, what's going on? Okay, so here the default is to make these solid black circles, okay? Solid black dots for the points, okay? You can specify things like shape equals 21 and you'll get open black dots. And you can always ask, well, what are the different, you can just ask, what are the different shapes that I can do? And probably right here, just search for the images, and here's kind of a listing of things. I guess those ones have names. These ones have, oh gosh, okay. Different things that you can do, okay. So always, the internet search is your friend to find the things that you're looking for. Here I'm changing the size of the dot, okay? This is again as a setting. So if you want to make bigger dots, you can do this. And again, almost anything that can be a setting can also be mapped to an aesthetic, right? So we can, rather than just specifying everybody gets size 3, we can also map it to a variable. Okay, so here I've changed the setting to size 3 so we can get bigger dots, but I've mapped the sex of the person that we looked at to the color, okay? And so looking at this, we can see when the people are around 12 years old, okay, there's a pretty good mixing between, as far as heights of boys and girls, the red and the blue dots, or the teal and the salmon dots, they're all kind of mixed together. But as we approach, age 16, 17, 18, there seems to be more pronounced difference between, mostly blue dots up here and mostly reddish dots down below, okay? And so, that's something interesting to see. This is just different people. Here we've mapped the shape, okay? And this is not as pleasant to look at, okay? But you can imagine if you had to print this out or something, maybe this is the only option you have to communicate, different things. And so by default, it chooses circle for the first thing and triangle for the second thing, okay? Circle because F comes before M, so circles, and then we get triangles, and this is what we see. You could choose, again, just like everything else, you can choose the scale and say, the scale, there should be a shape, scale shape manual, and you can specify which shape it is that you want for each thing, okay? So again, if you're trying to remember like what thing to search for, you have to think, okay, here I'm changing from a value in the data to an aesthetic attribute. That's going to be a scale, okay? It doesn't feel like a scale. It's not like we've got small numbers and big numbers, but it's we're mapping one of the values in the variables to a value, an attribute of the visual. If you need to plot data from different tables of data, okay, that's also possible, all right? So here I've created a graph, a function that is going to just, I guess I wrote sine x, but I used cosine x, okay, so forgive me, please. And so anyway, I've got, x going from 0 to 6, and f of x is going to be the result where I just kind of sequence along this. This is vectorized, and I could have just applied the function, but as you are aware, if your function has an if statement or something like that, that's not a vectorized operation. So anyway, what we have to do is we have to make it into tidy data. So I've got creating a data frame where one column is x and one column is the f of x. All right. And so here I've just got I'm going to do ggplot x is x and y is f of x. Okay, and we're going to say we want a blue line size 1. Okay, so that's just a setting. We're not mapping anything. And here I've got the cosine graph. Okay, and so let's say this is one of your data sets, and let's say you now need to include data from another data frame. Okay, and ggplot allows you to do this. So here I've just created another data frame called df points, which is just some random normal data. Okay, where I've got the column xp and the column yp, and we're just making a data frame there. Okay, so over here, p is I called ggplot on this thing. Okay, so ggplot is the original data set, and what I want to do is I want to add points to it. Okay, and so in order to add points, I leave this original ggplot call intact, okay, which is currently the data frame function data with the aligned geometries, okay? And basically on top of that, I'm adding point geometries, and I'm mapping the x to the x and the y to the y, but I have to specify that the data is coming from a different data frame, okay? And so this will allow ggplot to recognize, okay, we've got a different data frame, but we still want to add it to our currently existing ggplot. Okay, and so when you do that, here's just our random data points that we've kind of plotted, and they show up as well. Okay, so I mean this doesn't really mean anything. It's just I've got some random x and y data in this plot over here, and then and that's going on top of the cosine plot on the other side. Okay. We'll start covering some numeric methods, and your next homework assignment will require you to plot some line segments and stuff. Okay, so anyway, here I'm creating a third data frame. Okay, and you can see just all of these things. you know, this is P is now the cosine curve plus the points, and here to that I'm adding to that some segment, geom segments, okay? And so with segments, what we have to plot to create a segment is you need a x and y coordinate for the beginning and an x and y coordinate for the end. Okay, so you need 4 data points, and so you need 4 columns in your data, which might require you to reshape some of your data in order to get these 4 columns. And so here I just did random noise. Okay, I just said I need 8 points. You know, random normal for x1, random normal for y1. Random normal for x2, and random normal for y2. Okay, so these are just some random points, and we're just going to draw, I guess, 8 segments scattered around the thing, where the beginning and end points are random. Okay, but this is just to illustrate that we have a third data frame with 4 columns, and each of those 4 columns are mapped to one of these aesthetic attributes, the x and the y of the start and the x and the y of the end point. Okay, and so these are just 8 random segments that it's basically I have 16 random dots, and I just connected 2 that have been selected at random to make these kind of random points. So this plot represents nothing of significance, but it's created in a way where you can combine data from different data frames. Okay.
You do Monte Carlo method for area.
You could do a bunch of Buffon's needle drops type things for a Monte Carlo method if you were so inclined. Okay. But anyway, these are just some of the things. Again, my encouragement as you are considering making. So I give you homework, and you have to do the homework assignments, right? But the hope is that the stuff you've learned here is going to be useful for other stuff that you might venture on to do. And I certainly can't cover everything that you need to know about ggplot2. But the documentation website is very good. And if you just need a place to get started, the cheat sheet is an excellent place to just take a look and get started, because it kind of just shows off like the very, very basic ideas of what each kind of plot does. And you can say, oh, I kind of wanted to do something like this. Then you'd say, okay, what is this geometry that I need to make? Then you go to the documentation for that geometry, and then you can look up how exactly you're supposed to use it. Okay. Here we just covered the basics: the bar plots, the scatter plots, and the line plots. But I think that's a good start, and gives you an idea of kind of the framework upon which ggplot works. Okay. All right. Well, we'll end there for today, and we'll see you guys on Wednesday. Okay.